Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm very happy about this and I'm glad that I was able to come up with my own solution to this question without any help. So let's go over it and let me show you how I did it. So this is question 1631, path with minimum effort. So basically you're given this 2D grid, a matrix of heights, and you want to go from the top left to the bottom right, and you want to find a single path from the source to the destination where you're basically finding the minimum of the maximum absolute. So each path, you're going to find the maximum absolute difference of any two cells, and then you're going to find the minimum of all those maximums. So for example, in this path, that would be 2. That's going to be the maximum difference. This path, so let's simulate this again. So you can go down, left, up, right. And for this path, you're going to find, so you're trying to minimize the difference. So in this case, it'd be 2. In this case, it would be 1, and then at the end you would find the maximum of those, which is 2, maximum absolute difference, and then for each path minimize any of consecutive cells. So hopefully that makes sense, and let's go ahead and do that. So let's first keep track of the absolute difference, which can never be smaller than 0 as a general rule, and then let's keep track of the x and the y coordinates. So yeah, because we're starting at the top left and we're trying to go to the bottom right, and because we're trying to minimize this difference, let's heapify our queue and treat it as a heap to sort by this, and then by this, and then by this. So let's also create a set called scene so we don't visit the same thing twice, and let's just get the number of rows as m and the number of columns as n to get the dimensions of the matrix. And let's just keep running a BFS while we can. So let's also keep track of all 4 directions because we're going to move down, left, up, right. So 1, 0 is down, negative 1, 0 up, 0, 1 is right, 0, negative 1 is left. So now let's go ahead and heap pop from our queue, and we're going to get the difference and the current x, which is the height, and the y, which is the width of the coordinate of the grid. And if x and y is ever in scene, then continue, because that's how you avoid infinite loops. And then let's add our coordinate to our set so we don't ever visit the same coordinate twice. And then let's go and traverse each direction, down, up, right, left, right? We have to try each direction from each cell. So new x, new y would be x plus dx. We're applying the change that the direction gives us, right? We're going in one of the 4 directions. And at any point, if we're out of bounds, outside of the bounds of the grid, or ny is bigger than or equal to the length of the grid, then we're just going to continue because that doesn't count. We can't process a cell that's out of bounds. And then in this case, we're going to find the current difference, which is going to be the minimum of whatever the previous difference was, because we're trying to minimize that in each particular path that we can explore in a greedy fashion. And let's call this the current difference, which is just the absolute value of the current cell's value that we just popped, right? Because from that cell, we're coming to another cell in 4 directions, so not diagonally. And that we're going to subtract our new cell that's in bounds to find the absolute difference and minimize it. And then we're going to push back onto our queue the current difference, and then the new x and the y coordinates that we're moving to, up, down, left, right. Cool. All right. So at any point, if x is equal to m minus 1 and y is equal to n minus 1, we've reached the dimensions of the grid and we can print our difference. So in this case, that's 0, so that's not correct. So looks like we're actually trying to maximize this, so you might have to play around with it a little bit. Cool. So now you get 2 and 1. The wording can be a little confusing, but if you just try minimum and maximum, I think you'll eventually find it. And then here, let's declare our answer as 0 because we're trying to maximize it. to the difference, or we're trying to find the minimum of the maximums. So let's just actually create a sorted list just to make this a little less confusing. And we're going to add difference to keep this in sorted order. So the leftmost element of the sorted list would be the smallest element, or the answer that we need. So let's run this, submit it, and there you go. Passes all test cases. So again, I'm super happy that I was able to solve this question completely on my own without any help. So yep, that's it for this video, and that's for 1631 path with minimum effort. This is a medium level graph question.